In example 39, we've got one more product to find in this section, and we're going to probably notice something a little strange happening that we're not used to, but let's see what we get. Let's start off by examining these matrices just to make sure that the product exists. So this first matrix here, this is a 2 by 2, and the second matrix is also a 2 by 2. So we see that we can multiply them, and we will end up with a 2 by 2 matrix. So the elements in the first row, I'm just going to take this first row and multiply it by each of the two columns to get those entries. And in the first entry, we're going to add 2 plus a negative 2. And in the multiplying it by the second column here, we've got 6 plus negative 6. Moving on to row 2, multiplying by column 1, we've got 6 plus negative 6. And multiplying it by column 2, we get 18 plus negative 18. And so cleaning this up, we find that we have the matrix filled with all zeros. So the interesting thing that's happened is that we've taken two matrices, two non-zero matrices, and the product we got was the zero matrix. So it is possible to find two non-zero matrices whose product is the zero matrix. That's pretty odd for us. In mathematics, the way we describe this type of situation, we call these zero divisors. We're used to situations where, if we multiply two things together to get 0, it seems that one of them must have had to have been 0 in the first place. The real numbers are an example of a structure like that. If you multiply two numbers in the set of real numbers and get 0, then it must be the case one of them was 0 in the first place. That's no longer the case with matrices. It is possible to find two non-zero matrices to multiply and give you the zero matrix.